Hello, everybody. So what we're going to be looking at today is section 3.1 in your book, which is algorithms. So we're kind of done with sets for now. So we're not going to be looking at any more sets. We're moving on to chapter 3, algorithms. And so this is kind of going to be a programming section. But what we have to do is we have to get through this theory section first. And then you're going to have a programming assignment where you have to code up a number of algorithms. So that will be fun for some of you. And yeah, but let's go ahead and do this lecture to get the theory out of the way. I think that our next lecture is also going to be from this section in the book where I go over a couple specific algorithms, and then we're going to have a computer lecture where we go over some of the code. Anyway, let's go ahead and get started. So what is an algorithm, right? So it says it right here. This is the definition in the book. So an algorithm is a finite sequence of precise instructions for performing a computation or for solving a problem. So the key there is really that it's supposed to be finite sequence of precise instructions. Okay, that is what we're getting at. So it needs to be, well, what does it need? So your book actually goes to more trouble than most textbooks would go to, and they have very specific requirements for what it means to be an algorithm. For us, generally it's going to be, this is going to be good enough, right? Finite sequence of precise instructions for performing a computation or solving a problem. But we need a little bit more than that to meet the requirements set out in your book. So what properties do we need to have? So an algorithm is going to be solving a problem, right? Often an algorithm is going to be operating on a specific thing, like a number, right? Like, so you might have an algorithm for finding, I don't know, like let's say the average of a, I don't know, list of numbers, right? That's something that you could do. Now, I'm not going to write out what that algorithm is, but if you were operating on a list of numbers, right, every time you performed your algorithm, you would have a different set of numbers. And so to make your algorithm work on every set of numbers, you would have to provide those numbers as input to the algorithm. Okay, so you need input. Now, not every algorithm needs input, but most do, right? Just like this. If you're finding the average of a list of numbers, you need the numbers. That's your input. Okay. Next thing we need is an output. Again, not every algorithm would necessarily have an output per se, but most are going to have an output. What's an output? Well, that would be whatever is coming out of the function, of course. So if we were finding the average, right? Finding the average of a list of numbers, then whatever the average is, that would be your output. So you produce the output. Your algorithm takes in the input and produces the output. That stuff is pretty simple. The rest of these kind of requirements here, what they are is it's just stuff to make sure your algorithm is really going to actually work. Okay, so what are they? So definiteness. So the steps of an algorithm must be defined precisely, right? You can't just have a step that says step 1, find the average, right? That couldn't be your algorithm for finding the average. You can't just say step 1, find the average, because the whole point is, well, I don't know how to find the average. This is supposed to be telling me, like the algorithm is supposed to produce the average. So you have to make sure that your algorithm, each step is something that, is defined precisely. So like this would not be allowed, what I just wrote here. right? That would not work, not precise. I don't know how to find the average. Okay. The next thing is correctness. Well, an algorithm should produce the correct output values for each input. Well, yeah. If you have an algorithm that's supposed to do something and sometimes it's wrong, that would be bad, right? So, I mean, that's obvious. If output is sometimes wrong, not a good algorithm, right? I'll just say not an algorithm. It doesn't solve the problem then. Next thing, finiteness. Now, both finiteness and the next one, effectiveness, both talk about finiteness or something being finite. So it's a little bit tricky to keep these separate, but they do mean different things. So finiteness. So the algorithm should produce output after a finite number of steps, right? So this is, let me highlight it here. Finite number of steps. Okay, so if you have an algorithm that produces the answer, but it takes an infinite number of steps, that's bad because you'll never finish, right? So if number of steps equals infinity, that's bad because it will never complete. Next one, effectiveness. It must be possible to perform each step in a finite amount of time. So the previous one, finiteness, has to do with number of steps is finite. Effectiveness means that each step individually takes a finite amount of time. Okay, so that's a little bit different. So this is each step, finite amount of time. And then finally, generality. Generality means that the procedure should work for all of the problems of the desired form, right? So if you have an algorithm that's supposed to find the average of a list of numbers, it's not good enough to work on some lists of numbers. It needs to work on all lists of numbers. Otherwise, it's a bad algorithm. Okay? And so, assuming that your algorithm does all of these things correctly, then it is, in fact, an algorithm. All right. Now let's talk about pseudocode because you're going to be looking at pseudocode a lot in the upcoming programming assignment. Okay. So you know pseudocode probably from other programming classes, but still, we will talk about it here. So the idea behind pseudocode, which is defined actually down here, but when you have an algorithm, I could write all of the steps in English for you, right? And I could also write all of the steps in a programming language, right? But neither one of those is ideal because if you write it in English, then you might not know how to do it on a computer, right? Like kind of like what I wrote up here, right? If I say step 1, find the average. Well, like how do you do that on a computer though, right? I said find the average in English, but I didn't say how to find the average. That's bad. Okay? So if you write it in English, that's the sort of problem that you have, is that you don't know how to write the code because you wrote it in English. Now, the next thing you could do is you could write it in a programming language. Well, if you have an algorithm written in a programming language, then it's sometimes hard to figure out what the code is doing. You probably know that too, right? You've looked at code that other people have written. It's hard to understand, isn't it? Right? And so if you're looking just at code, then that can be hard to understand what's going on. And so most books, including ours, rewrite algorithms with pseudocode instead. And so what pseudocode is it's kind of partway between English and a programming language, right? So intermediate step between, English language and in a programming language. So halfway between, okay? So it looks like a programming language, but it should be easier to understand. So it's like, looks like a programming language, sort of, but hopefully is easier to understand. And so the reason it's going to be easier to understand is because you don't have to worry about all of the things that you have to worry about with a real programming language, like types and, how do you end things? Do you use curly braces? Do you use semicolons? All that kind of stuff. You don't have to pay attention to it when you're doing pseudocode. Now, just to be clear here, you're not going to be writing pseudocode for this class. You're just going to be reading pseudocode in the book. So that's actually pretty easy for you guys, I think. So, don't stress out about pseudocode. Now let's look at an example of what the book's pseudocode looks like for you guys. So here's a very simple algorithm. So what does this algorithm do? It finds the maximum element in a finite sequence. That's a very simple thing, right? Find the maximum number, right? So the idea is, I give you numbers like this, 5, 13, 1, 7, 6, 23, right? And then what is supposed to happen is your algorithm is supposed to go through these numbers, and it's supposed to find that 20 is the biggest number. There it is, it's maximum, and that's what it's supposed to find. So that's a very simple thing to try to do, right? And here's how we're going to write this pseudocode. And so this is what you need to understand. So let me get a different color and we can write on this. So first of all, they say procedure. Why do they say procedure? That's just telling you that they're implementing a function, right? So start of a function is what procedure means. Okay. Then you've got where it says max. That is the name of the function. That's where they put that. Name of the function right there. Then you've got these, A1 through AN. That is your input to the function. And then integers here, that is telling you what the data type is, but you don't need data types in Matlab, so you're never going to really pay attention to integers or whatever it says there. Data type. And we won't need that. We don't care about that. Okay. Now, then what you get is actually the pseudocode. So what can we say about this? So a couple of things. First of all, if you look here, so this right here where it says max colon equals A1, colon equals there, that's how they write an assignment. So they are setting max equal to A1. Okay, so this is assignment. So like max colon equals A1 means set max to A1. Okay, so you're actually assigning a value to a number. So in a programming language, that's usually equals. So in Matlab, it's just equals. You would just write max equals A1. Actually, there's no subscripts, but you get the point, right? Equals is the point. Okay, now let's look at the next line. We have a for loop, right? We're starting a for loop. Now you have to be careful about the way that they write these. So they write for, and you can understand this, I think, I equals 2 to n. So that's what we're using for our for loop. Starting and stopping values for the for loop are 2 and n. And then what's inside of the for loop is anything that's indented. Okay, so like this line right here, this is inside of the for loop. But this line right here is not inside of the for loop because it's not indented. If this was moved over to where the if is, then the return statement would be inside the for loop, but it's not. Okay, so you have to pay attention to those because there's no curly braces or anything like that, or ends even, to tell you when a for loop ends. Okay, so just if it's indented, it's inside the for loop. So like, right, indented, indent, means inside the for loop. And then finally, we got, what do we have at the end here? We've got a return statement that's outside of the for loop, and that's relevant for languages such as Java and C++, but we never actually use, well, I shouldn't say never. There is a return command in Matlab that we don't use very often. But in other programming languages, you do, right? So this means return a variable, return, but we don't usually do that in Matlab. Rarely use that in Matlab. What you do need from that line, though, is the output variable, right? Because in Matlab, you need to say your output variable at the beginning of the function. So here it says return max, and so you've got max right here, and that's actually your return variable, which you specify at the top in Matlab. Is the output. So the return variable is the output. Okay, so I drew all over that. Now it's hard to read, but there's another copy that's clean of this PDF that you can look at if you can't read what I'm writing here. Okay, so let's check that this actually meets the requirements to be an algorithm. Okay, so let's go through these one by one. So input. So does this have input or need input? Yes. An algorithm has input values from a specified set. So what is the input for this function, right? We already said the input is A1 through AN, right? Right here. This is the input. So yes, it has it. So I'm going to say yes because it has it. And then what is it? The input is A1, A2, up to AN. That's the input. Okay. Output. That's next, right? Yeah, it is. Output. So what's the output? Well, output is max right here. It's the max variable, which should be the maximum value of the list. Max. That's the output. I'll say output is max to match up with what I wrote on the line before. Okay. Definiteness. Definiteness. What's definiteness? Scroll up and we'll read. So definiteness. Definiteness is the steps of an algorithm must be defined precisely. Yes, of course they're defined precisely, right? Everything up there made sense. We didn't even go over what was happening, but everything was defined precisely. For loop with specific starting and stopping values. We have an if statement, which we're going to write this in MATLAB code, so it'll make sense then if it doesn't now, but that's precise. It's just an if statement. We know how to do that. We know how to do everything in here in code. So yes, every step is precisely defined. Every step is defined. They all make sense. We know how they work. What's next? Correctness. So correctness is an algorithm should produce the correct output values for each input. So it needs to come up with the right answer. Now, of course, an algorithm from the book like this one, of course, it's going to produce the correct values, right? They wouldn't be giving it to you and telling you to code it up if it was not going to work. But if you go through this and see how it works, what it does is you store you have a list of numbers, A1 through AN. You store the first one into a variable called max, and then you loop from 2 to n. So we're going to loop through every other element in the list. And we compare maximum, the maximum variable, to the next number in the list. And if the number is bigger than our maximum, then we store that number as our new maximum. So that way, as we're going through the list, we're just keeping track of the biggest number that we saw. So you start out max is A1, and then you go A2, A3, A4, A5, and anytime you see a number bigger than the current maximum, you store it as the maximum. And then when you're done with this loop, maximum should just have the biggest value in the list. So is that a correct algorithm? Sure, that should work, right? It's going to work. Yes, looks like it works. It should produce correct output. We don't know until we do it, right? But it looks like it should produce correct output, which is what the step is. Finiteness. So remember the difference between finiteness and effectiveness. So finiteness, I believe, was finite number of steps. And yes, this has a finite number of steps, right? We're looping from 2 to n. So however big n is a number, we're just going to go through and do that many steps. So we do have a finite number of steps, which is what finiteness is. Yes. Finite number of steps. Why? Because we're looping, right? Because we're looping from 2 to n, right? And n is a number, so that's not going to be infinitely many times through the loop. Okay, so that should be fine. Then we get to effectiveness. Effectiveness is every step should be finite in time. So you just have to look at the operations and think, okay, well, is there any way this could be infinite time? No, that's just assigning one number to a variable. Here we have a loop. We're going 2 to n. So we know there's n steps, or n minus 1 steps, I guess. But we have an if statement. There's a comparison. That should take finite time. We set a variable equal to another variable. That should take finite time. And then we return. So everything is, not like there's no way any of these things could take an infinite amount of time individually, right? So yes, every step looks finite time. Every step takes finite time. I don't know how long it takes, but it should be finite. And then generality, and generality was the function should work in general. So like it shouldn't be hard coded to find the maximum of one specific list or something, right? So it works for all inputs. And yeah, right, it should work for all inputs. Should work for all inputs. All right. And so if your algorithm has all of these properties, then it's a good algorithm. It should work. Everything should be fine. And that's what we're talking about in this section. Okay. Now, the thing is that the pseudocode, though, doesn't quite match up with Matlab code. And so I have kind of a little kind of list of stuff to pay attention to here that we'll talk about. But you should understand what I'm trying to tell you here, because this is good advice. So this is differences between the book Pseudocode and MATLAB. Okay, so what are some of the differences you need to be aware of? Okay, so one thing is on the inputs. So in this pseudocode, right, they say you have A1, A2, A3 up to AN as your inputs. Well, MATLAB is really good at dealing with vectors. So you don't want to pass a bunch of variables in. You just want to pass one single vector in. Okay, so that's just how MATLAB likes to work. So if we're passing in a list of numbers, you don't want to pass in a bunch of variables. Instead, you pass a single vector, right? So you don't want your first line to look like this. Function max equals, actually, let me hold on here. You can't call everything max the way that they did either, by the way, but like I'll use like m equals max. Like you don't want this, A1, A2, A3, because if you do that, you're going to be hard coding it to a specific number of numbers, right? Like if I stop here for my first line, then that would be a max function that only works if you give it 4 numbers, and that would be bad, right? So you wouldn't want this. Bad. What would be good? Good would be to have a vector for your inputs. So you just say function, m is our output variable here, equals max. And instead of doing A1, A2, A3, A4, you just say max equals A. Like that, not max equals A, max of A. And then the idea is that A is a vector with inside of it A1, A2, dot, dot, dot. Right? That's how you do it. So in MATLAB, we'll always be doing that. Now, another thing to notice about that is if you look at their code here, the input variables were A1, A2, up to AN. So there were n different numbers here. And they needed to know how many numbers there were because in the for loop says I equals 2 to n. N is the number of numbers. But if we're going to be passing in a vector, right, our code's going to look like this. M equals max A. So where's the n, right? We need to know how many things are in the list, okay? And so what you're going to have to do basically is add an extra line to calculate n that they did not have to write. So like we're just basically going to add a line like this line into your code somewhere. N equals length A, right? Where length is going to give you the number of things in the vector, and that's what n is supposed to be, so that will work fine. Okay, so it's not in the pseudocode at all, but you're going to need it, otherwise you're going to have like an undefined variable n. Okay, next thing. Pseudocode specifies which variables should be returned. MATLAB specifies return variables at the top of the function. You don't use the return command usually. We already talked about that. But like if we start our function like this, function m equals max, this right here, this capital M, this was my output variable. So I was making it an output variable right there, even though I didn't say it, right? That's where you put the output variable. Okay, so just be aware of that. Book doesn't use MATLAB syntax for loops and if statements. They indent the commands. We already talked about that. But you need to not forget to use end. You have to use end because you're writing it in MATLAB. Okay, so just be aware. Also, MATLAB contains a lot of shortcuts that can save you time. We're not going to use the max command to implement max because it's already built in, and we're trying to write our own code, not use the built-in code. But there are a lot of built-in commands that you could use instead of what we're trying to write. So let's do this. Let's try to implement the max function the way that they wrote it. Okay, so how would the code look? So the code would look something like this. So first of all, I'm not going to call it max because the built-in one is called max. You can, but it makes it hard to tell whether or not you're running your own function or you're running their function. So I'm going to call it something different. So I'm going to say in a file, let's call it mymax.m. Okay, so my function is going to be called mymax. That way I don't confuse it with MATLAB's max. Okay, so what do we do? So first of all, we say function. We need an output. So I'm going to use capital M for the output. I guess I could use capital MAX. Actually, let's do that. Capital MAX equals. Now, then we have the function name, mymax, and then we need the input, and the input is A. So again, we know that the way this is going to go is that this is a vector, so it actually has a bunch of numbers in it, and that's our input. And the maximum here, that is where the output goes. And this is the name of the function. Okay. So that's how we start. Function max equals mymax.a. All right, let's continue on. Now from here on, we should basically just be copying the pseudocode. But before we copy the pseudocode here, remember this in that we just talked about, right? They use in, we don't have in. So even though it's not written up there, we need an in. So my first line is going to be this. Oops. In equals length A. Okay, so that's extra, but we need it. What's next? Now we can actually start following the pseudocode. So the first line that we have here is max equals A1. Max equals A1. Now, it's going to look a little different in MATLAB code. First of all, I decided to use uppercase here because I don't want to conflict with the built-in max. So uppercase, MATLAB's case sensitive, equals, and it's supposed to equal A1 like this, right? But that is not going to work because there's no subscripts in MATLAB. So A1 is not actually a subscript 1. A1 is A1 like this, right? No subscript. So just be aware of that as well. A1, not A1. Okay, that's how it has to be done in MATLAB. All right, I think we're on to the for loop now. So the for loop is from 2 to n, right? For I equals 2 to n. You have to remember how to write a for loop in MATLAB. It's not quite like this. 2 to n though. I goes from 2 to n. How does that look? It looks like this. For I equals 2 colon n. That's how it looks like in MATLAB. What are we doing? I think inside of the for loop, we have an if statement. Let's look at it. If max, here we are, if max less than AI. If max less than AI. Do that. If max less than AI. Again, notice how we're doing the AI, right? No subscript. If max less than AI, what do we do? Well, I didn't get that far. Scroll back up. So if max less than AI, then, by the way, there's no then in Matlab. That's not a thing. So what are we doing though? If max is less than AI, then max equals AI. Okay. So if max less than AI, then, you don't write then, max equals AI. I don't want to see that on the screen, so I put a semicolon. And I think that's it for the if statement, right? So looking at the if statement, the entire if statement is just this one single line. So the if statement's done right here. So we already are done with the if statement. And then as well, the next line is not indented. So for then this if statement, once you're done with the if statement, you're done with the if statement and you're done with the for loop. So we need to end the if and end the for loop in Matlab. So in order to end the if statement, we have to say end. And then in order to end the for loop, we have to say end. And now we've ended, what have we ended, right? This matches up with this matches up with this. So we ended the for loop, we ended the if statement. What's left? What's left is just to return, right? Return max. But actually in Matlab, you don't have to say return. It returns automatically at the end of the file. So this is actually done. We don't even need anything. So I can just say end, and that would be the end of the function, right? We don't need no return needed. When it gets to the end of the file, it will return, and it knows that the return variable is max. So there you go. That's your Matlab code for a max function. Make sure you remember how to do this in terms of like that right there. The name of the function needs to match the name of the file. Yeah, and it should work. Okay. Let's see here. How far are we? We are 38 minutes. So I think we'll do this one next function and then we will stop. I know that there's actually another algorithm at the end, but we need one more lecture on this topic. So we'll stop after the next algorithm and pick up in the next lecture. All right. So mostly what we're going to be doing in this section is looking at searching and sorting algorithms, right? So we got, in this section, we got search and sort algorithms. And so what kind of searching methods do we have? Well, we've got linear search. We've got binary search, which I think you're going to code up. For sorting, how are we going to sort something? We're going to sort things with what do we have? Insertion sort. There's like let's see. Insertion sort, bubble sort. I don't know what else. It's good enough. So these are algorithms that you've probably seen in other classes. The only thing that you want to be aware of is when you do the code for this class, you need to use R algorithms. So if your code is not like, if you were coding up the linear search algorithm, you would be required to use this algorithm. So don't tell me Don't give me the code that looks like, Kathy Kanemoto's code for another class, right? You got to use this algorithm for our class. All right, let's talk about this. So linear search. So linear search is going to be this. So you've got a list of numbers, right? So you have a key. Like, so you have, here's an example. Like the key could be x equals, 7. And then your input could be like a equals, what's this? 3, 5, 7, 13, 50. They don't have to be in order. 20, 10, 2. Right? Just a list of numbers. And what linear search is supposed to do is it's going to look through the vector A, so 3, 5, 7, 13, 50, 20, 10, 2, and it's going to try to find a 7 in there. And what it's going to return, if you look, returns location. Location is the subscript of the term that equals x, or 0 if x is not found. So what was supposed to be returned if you gave it this data right here is it should say, like, returns 3, because the 7 is in the third spot, right? You have the 7 in the third spot. So that's how linear search works. Actually, that's not how linear search works. That's what we're doing. How linear search works is it's literally just going to check if x is the current A. So you check if 7 is 3. If not, you move on. Check if 7 is 5. If it is, you're done. If not, move on. Then you compare the 7 to 7, and you're going to stop, right? So you just go 7 to 3, 7 to 5, 7 to 7, 7 to 13, 7 to 50. You keep doing that, and then you just stop when it matches. And if it never matches, so you get to the end of the vector with no match, you're supposed to return 0. Okay? And you don't have to think about how to make that happen, because the algorithm should be doing that for you, right? You're not supposed to have to think about this. They already thought about it, and you're just supposed to write the code, and it's just supposed to work. Okay? But that's how it's going to do it. It's going to go one by one, 7 to 3, 7 to 5, 7 to 7. Okay, so let's try to do this. How are we going to do this in Matlab? How much room did I give myself? Not much. All right, so what is this code going to look like? Something like this. I'm just going to write it here. Function. So where would this be? This would be in like linear search, maybe, .m, whatever you want to call it. And you're going to start it function because it's a function. Our output's called location. I probably don't want to keep typing location, so I'm just going to write LOC. I changed my mind already. I'm going to write location equals the name of the function, so linear search, and then the input. What's the input? So the input, now we have more than one input. We have an X and we have an A vector. So A1, A2. So A1 through AN is just like before. X is a single number, just like what I showed up here. So our inputs are, you have 2 of them now, X, A. Now, A is a vector, but you can't tell that from just looking at what we just wrote. But A is a vector and X is a number. Okay, let's start. What do we do first? Well, again, look at this. Later on in this code, you see this in, right? You need in. In is the length of the A vector. They don't calculate it because they already know it. We don't know it. So it's like we have to basically add this to our code. Otherwise, we're not going to have in, and we need in. So you add that extra line. Now we can start the code. So what are we doing? We're translating this line by line into Matlab. So first line, I equals 1. I equals 1. Okay, did it. Then we got a while loop. So while loop instead of a for loop, that's fine. While I less than or equal to n, okay, we can do that. Let's try to write that. While, parentheses, I less than or equal to n, that's how you do that in Matlab. And, right, we got an and here. And, there's going to be two ands, just like C++ or something, or Java. X not equal to AI. X not equal. Now, not equal is like this in Matlab. That's a tilde equals, not a exclamation equals. So X not equal to AI. Remember, no subscripts, so it's like this. So this is a little bit different than you might expect, but that's how you do it in Matlab. Inside of the while loop, we just have this, I equals I plus 1. Very simple. Just write it. Okay. End. Then we end our while loop because this is the only thing that's indented. That means it's the only thing inside the while loop. Just this. Now, just a comment for what's happening here. So it's using this while loop to do the comparisons, right? Because it's actually right here. This part right here is checking whether X is equal to AI. And if it's not, then we check, then I counts up by 1, and then we check again. And then I goes up by 1, and then you check again. So that's what's making it do this. 7 and 3, 7 and 5, 7 and 7. It's all right here in this part, which compares X to AI, and this part, which increments I to go to the next A value. Okay, so that is the while loop. Now, when it does this, there's going to be two possibilities. Either it found a match or it didn't find a match. Because remember, what we're supposed to do is we're supposed to return 0 if we didn't find X. But how are you going to know if you found X? Well, we're going to check. Because there's only n things in the vector, right? So like, here's the idea. So if you look at this example here, you have 1, 2, 3, 4, 5, 6, 7, 8, right? A has 8 things in it. So if you run through this while loop right here, and then you get to the end, and if somehow I was 9, then that would mean that you actually checked all 8 of these and none of them were equal. And that's how I would be 9. And so that's what's happening here is we're going to check if I is less than n, which would mean that it found it in the vector. So if I is less than n, then we did find the thing we were looking for. Otherwise, the location must be 0, because if I is not less than n, then that means that we checked all of them and we ran off the end of the vector. We went to the end and then went past the end. Okay, so that's how it works. But we just need to write it. We don't even need to know how it works. So we got our while loop, and then now we got this if. How does the if statement work? If, just read it, I less than equal n, then, but remember there is no then, location equals I, location equals I, else, right? We got an else, location equals 0. Those could probably both have semicolons. Now, it doesn't say it, but after this else, that must be where the if statement ends. So you have to realize that, so you can add the end right there to the end. And then what's left return location. But remember, you don't actually have to say return location. You already said location was an output here. So this line contributes nothing. So we can just say int. And so the idea here is this end is for this if statement. This end is for the while. And this extra end is for the whole function. Okay, and there you go. There's another function implemented in Matlab for you. Okay, so in the next lecture, what we're going to be doing is we're going to be talking about more complicated algorithms. We're going to be talking about binary search. We're going to be talking about bubble sort. We're going to be talking about insertion sort and that kind of thing. So different sorting and searching algorithms. Okay. But for now, yeah, this is where we stop. So I will talk to you guys later. You have a test coming up, so study for that. And yeah, that's it for now.